Hi grade 9s, it's Miss Longarage here, and today we'll do the second part of lesson number 4 from assignment number 4, where we're going to talk more about the SUV and the minivan and how much gas both of those vehicles use. So before we begin, I say this every day, but I really mean it, please get a pencil, a piece of paper, a calculator, so you can do some math along with me at home while you're watching this video. It's really going to help you understand better, learn better, and you'll be so much better off if you do math with me. So we're doing lesson 4, I said. This is the second page of lesson 4. But before we do that, what I want to do is I want to check our homework from last night. So our homework from yesterday was to make a table of values for the minivan. So here I've made a table of values for the minivan. I know it started at 65 and it dropped 0.15 every D, and the table of values ends up looking like this. What I would like you to do is I would like you to press pause, and you have two options. Either check your work that you already did for homework last night, or I want you to try this question, making the table of values for the minivan on your own, and check to make sure that you can get the right answer. So today what we're going to start off with is talking about the rate of change and the initial value of the SUV. We talked a lot about the SUV yesterday, and we're going to continue talking about it today. So if I look at the table of values and the equation, I can easily find the initial value. The initial value is obviously 80. So we can fill out the chart for initial value. We can write down that the initial value is 80 liters. At the beginning, there was 80 liters in the gas tank. And don't get confused, don't say $80 because our second column is not dollars, our second column is liters. So that means it starts at 80 liters. The part that's trickier is finding the rate of change. We're going to have to do some math to find the rate of change. And if you look on the worksheet, it suggests that you do something a little bit complicated to find the rate of change. It says, do this. It says, take the G differences and divide by the D differences. And by taking the G differences and dividing by the D differences, you can find the rate of change. What does that mean? Well, the G differences mean how much are the G's jumping by. The D differences, how much are the D's jumping by. So that means we'd have to subtract the G's to find out what they are jumping by. We'd have to subtract the D's to find out what they're jumping by, and then we need to divide. So really, we're just doing subtract, subtract, divide. So that crazy sentence that you see in the assignment just means do subtract, subtract, divide. Subtract, subtract, divide. I know you guys really missed that dance, so I felt like I should add it to the video. So here's my table of values. I want to figure out how much it's jumping with the G's, and the G's should be jumping down 20, and then the D's are jumping by 100. So what I need to do is I need to do minus 20 divided by 100. And the great thing is we didn't actually need to do any math to find the rate of change. Just by looking at the equation, we can find it. We know that the rate of change is the number that's with the variable or the letter. So the rate of change is minus 0.20, and the initial value is 80, the part that's by itself. So we could have determined that right at the beginning just by simply looking at the equation. We need to go back to that table and complete it. So the rate of change is negative 0.20 liters every kilometer. That means you use 0.20 liters of gas every kilometer you drive. So your gas tank loses or goes down 0.2 liters every kilometer. Now, sometimes students have a hard time knowing what the units are after the rate of change. The way you do that is by looking at the table of values. So if I look at the table of values, we can see the units there and use them. It says the G is in liters and the D is in kilometers. So that means it's going down negative 0.20 liters every kilometer. Next thing we need to do is we need to talk about the two graphs, the graphs for the minivan and the graph for the SUV and talk about what is the same and what is different. So you can go to Desmos right now. You can enter the two equations into Desmos, and then we can talk about what is the same and what is different. So let's pause our video right now. So I've made the two graphs on Desmos, and I hope you have too. And what I want you to notice is something that is different is their initial values are different. The red graph starts at 80 and the blue graph starts at 65. Something that is the same though is that both of those graphs are decreasing. That means both of the gas tanks are losing fuel or losing gas as they drive. The other thing that is different is the rate of change. The red line is actually going down steeper. It has a bigger drop every time. It's dropping 0.2 each time, and the blue line is only dropping 0.15 each time. That's why the red line actually passes the blue line near the end of the graph. And here's another question. For the minivan, what does the ordered pair 100, 50 mean? So don't forget, we're talking about the minivan here, not the SUV. So you need to look at the equation and the table of values for the minivan. So let's do that now. If I look at the table of values, I see that the first number is the kilometers, and the second number is the amount of gas left over in the gas tank. So that means the 100 is the kilometers and the 50 is the amount of gas. That means if you've driven 100 kilometers, you only have 50 liters of gas left over in your gas tank. Okay, another question. It says, if the SUV is driven 250 kilometers, how much gas is left in the tank? We have to look at the graph for the SUV, so let's do that now. That was the red graph. So I'm gonna go to 250. On the D-axis or the X-axis. I'm going to go up to the graph, up to the red graph. I'm going to go all the way across, and I'm going to look to see how many liters of gas is left in the car after 250 kilometers. So just by looking at the graph, we can find the answer to that question. We can see that there's 30 liters of gas left in the SUV after 250 kilometers. If we were going to put that into, make it into a point, it would be 250, 30, because the distance comes first and then the gas. This whole unit, though, is about how looking at the graph and the table and the equation should all give you the same answer. So if you look for 30 liters in this table of values, you can see that 30 would come between the 40 and the 20. So the 30 would be right between that 40 and the 20. So if I look in the first column, that means the answer would have to be between 200 and 300. Well, what number is between 200 and 300? 250. So it makes sense that at 250 kilometers, the gas driven should be the gas left should be 30 liters. Just by looking at the table, we can find the answer. The last thing we want to do now is we want to find the answer using the algebraic model, so the equation. So here's our last step, our algebraic model. This right here, is this gas or is that kilometers? Well, it says kilometers, so that means it must be the D, the distance. So what I'm going to do is I'm going to take the equation, and don't forget, we're talking about the SUV, so you need to use the SUV equation. You write down that equation, it never changes. All you do is you cross off the D here, and since I know the D is 250, I put it in the equation, and then I have 80 minus 0.20 times 250, and that would be 80 minus, I'm doing mental math, 50, and that means my gas would be equal to 30 liters. So if you drive 250 kilometers, you'll only have 30 liters left in the tank. And what I want you to notice is that the graph, the table, and the equation all gave us the same answer. So that means we know we did not make a mistake. So you have no homework for lesson number 4. We've completed lesson 4 for assignment number 4. Your homework for tonight is to start looking at lesson number 5, the cellular phone problem. It looks like this. And what I want you to do is look through the problem and see if you can do some of that problem all on your own before I start making videos for it tomorrow. You have all the tools in your toolbox now to answer this question, so your homework is to try it on your own. If you need help for anything you saw today in the video or yesterday in the video, please come see me on Google Meet. I have a staff meeting today, so I will only be on Google Meet for an hour from 2 to 3 this afternoon, but I would love to talk to you then. Please leave me a comment in YouTube once you've watched this video. I hope you have a beautiful day, and I will see you tomorrow on YouTube.